3 days ago, one tweet started a new chapter in AI engineering. Peter Steinberger, the developer behind OpenClaw, asked, "Are we still talking loops or did we shift to graphs yet?" 500,000 views in a few hours, and the term graph engineering was born. If that sounds like hype, here is a number that is not. Anthropic measured a multi-agent system, beating a single agent by 90.2% in their internal research evaluation. So, in the next few minutes, you will learn what graph engineering actually is, why single agent loops hit a wall, which frameworks already do this, and we will build a real agent graph that runs on your machine with a local model, no cloud, no API key, and completely private. To understand graph engineering, follow the ladder. 2023 was prompt engineering. Craft the perfect words. June 2025, Shopify CEO Toby Lutke and Andre Karpathy popularized context engineering. Stop obsessing over wording, engineer everything the model says. February 2026 brought harness engineering. OpenAI described it with a horse riding metaphor. The reins, saddle, and bit that channel a powerful but unpredictable animal. Your job is the tooling around the model. Then, June 2026, loop engineering. Boris Cherny, who leads Cloud Code at Anthropic, put it bluntly, "I don't prompt Cloud anymore. I have loops running. They prompt Cloud, my job is to write loops." And now, July 2026, the fifth layer, graph engineering. One developer summed up the whole stack in 5 words: prompt, context, harness, loop, graph. Each layer engineers the system one level further out from the model. So what is everyone graduating from? The classic agent is a while loop. You give the model a task and a bag of tools and you loop. The model plans, acts, checks the result, fixes, and repeats until done. One brain, one thread, one growing conversation. And to be fair, this works. Cloud Code, Codex, most coding agents you use today are exactly this. Tex Horthy, author of the 12-Factor Agents Manifesto, described the pattern over a year ago. Ask the LLM for the next step, run it, append the result, repeat. His verdict even then, this approach just does not work as well as we want it to once the tasks get long. Here is why. Problem 1. Context rot. Chroma tested 18 frontier models and found performance degrades as input grows, and degrades faster when distractors pile up in context. A loop agent's context only ever grows. Every tool result, every retry, every dead end stays in the window. One critique described the end state as the context window becoming a garbage dump. Problem 2. Tasks keep getting longer. METR found the length of task agents can finish at 50% reliability doubles roughly every 7 months. Longer tasks mean more loop iterations, which means more rot. So problem 3, compounding failure. LangChain surveyed 1,340 teams. 57% now run agents in production, and their number one blocker is quality, ahead of latency and security. The math is cruel. A step that succeeds 90% of the time leaves you with about a 12% success rate after 20 steps. So graph engineering is the answer. Stop writing one loop, start writing a graph. Nodes do the work. An LLM call a tool or a whole sub-agent. Edges route between them. Fixed paths for the steps you understand, conditional paths where a decision is needed, and state flows along the edges. So each node sees only what it needs, not the whole history. The viral framing, agents are graduating from while loops to organization charts. Specialized nodes running in parallel, state flowing between them. And here is the neat part. A loop is just a special case of a graph. One node, one edge, pointing back at itself. You are not abandoning loops, you are admitting where your workflow actually branches. Does it work? The numbers say yes. with a catch. Anthropic built a research system where an Opus lead agent orchestrates Sonnet subagents. 90.2% better than a single Opus agent on their internal eval. The catch, about 15 times more tokens than a chat session. Structure helps even without multiple agents. The routine paper measured GPT-4o jumping from 41% to 96% execution accuracy on multi-step tool calling when a free running loop was replaced with a structured plan. And a real company, Rexera, rebuilt their real estate QC agent 3 times. Single prompt, 35% false positives, a crew of agents 8%, and an explicit graph 2%. So, quick pause. If you are into this, please do subscribe. This field renames itself every month and I track it so you do not have to. Now, the tools everyone reaches for first. LangGraph is the reference. Nodes are functions, edges are roots, 30,000 GitHub stars, MIT license. CrewAI layers event-driven flows on top of role-playing crews, 56,000 stars. OpenAI's Agents SDK does it through handoffs where transferring control to another agent is itself a tool call. Pydantic AI infers your graph's edges from type annotations. Mastra brings the same idea to TypeScript. And Google's ADK, Agent Development Kit, ships sequential, parallel, and loop agents you compose like Lego bricks. Every one of these is free to use. Even though it's all free, the secret is that you do not need any of those frameworks, and I will prove it by building the whole thing in about 25 lines of plain Python code. The only install from your side is installing Olama plus its Python packages, which talks to a local model on your machine. So I'm using a small model any laptop can run. One helper function, ask, sends a prompt to the model and returns the text. Now, the nodes, and they are just functions that read, write one shared state dictionary. The router asks the model to classify the request as code or text and returns the name of the next node. The coder drafts an answer, and if there is feedback waiting in state, it fixes the draft. The writer does the same for plain text. The validator grades the draft. On pass, it returns the word end. On fail, it writes its reason into state and routes back to the coder. And now entire graph engine in 3 lines. A dictionary mapping node names to functions, and a while loop that calls the current node and jumps to whatever name it returns. That is the whole thing. Edges are return values. State is one dictionary. The retry loop is visible and testable. And a normal user can read every line on one screen. This is what the frameworks are selling. This exact idea plus checkpointing, streaming, and dashboards on top. Now, for the pushback, because it is loud, Cognition, the company behind Devin, wrote a post literally titled "Don't Build Multi-Agents." Their argument: actions carry implicit decisions, and parallel agents that cannot see each other's decisions produce conflicts. So their rule: share full context and keep writes single-threaded. Anthropic's own agent guide says start with the simplest thing that works. Many patterns fit in a few lines of code, and success is not building the most sophisticated system, it is building the right one. Skeptics also point out that graph orchestration is not new. LangGraph and Autogen have done it for years. And one popular reply just called BS on the whole term, the sharpest critique of all. A graph without deterministic checks is just a more expensive way to build unpredictable systems. So here is a honest decision rule. Stay with one loop when the task is one domain, one writer, and fixed in context. A coding agent editing one repo does not need an organization chart. Move to a graph when you can name distinct stages with different rules. When parts can run in parallel without writing to the same place, and when you need checkpoints that a validator or a human can get. And still the hybrid that the smartest critics converge on. Keep loops for open-ended reasoning inside a node and use deterministic graph edges for the coordination between the nodes. So, recap, graph engineering is the fifth layer out from the model. Prompt, context, harness, loop, graph. Nodes do the work, edges route, state flows. The evidence, 90.2% better research from Anthropic, 41 to 96% accuracy from structure alone, 2% false positive at Rexera. The cost, more tokens and more moving parts. So start simple and add edges only where your workflow truly branches. The frameworks are free. The example we built is 25 lines of plain Python running on your laptop. And every source is linked below. If this saved you from reading 3 days of AI, Twitter, subscribe. And I will see you in the next one. If you have any questions, let me know in the comments.